Hi, so it was requested that I make a quick video about the tangent ratio. So sometimes it's, when we do a new topic, sometimes it can be difficult to kind of follow along with what's actually happening. So let me go ahead and start up my camera here. And I thought I had it launched already, but I guess it was not there. There it's coming. There we go. I'm going to pull this over in front so I can share that. So here we go. Let's see how this goes. So the tangent ratio, when the first thing that we need to do is understand kind of some terminology. So when we have a triangle, and it doesn't really matter where you're standing, because you could actually stand at either one of these acute angles, and we generally will call this right triangle trig. So it's kind of important that we actually are talking about right triangles when we're dealing with these. So typically we'll put the angle here at this bottom corner, but we obviously could put it in a different place as well. You know, you could have a similar looking triangle and be talking about this value right here. Well, if this is A, we will always call the side that is far away from it the opposite side. Of course, the longest side, the side across from the 90, is called our hypotenuse, and the one that is sitting right next to A would be the adjacent side. And I'm just abbreviating for speed. But of course, if this was B and I was talking about referring to things in relationship to angle B right here, the other acute angle, then the opposite would be the one that is down here because this base is really far away from B, but the side that is vertical is the one that is close to B. So opposite and adjacent kind of change in relationship to where you are looking from. Now, sometimes we'll say find the tangent. Sometimes we will say find the ratio, which means the fraction. Those are actually an equivalent statement. So frequently you'll have problems like this where maybe we put A right here and I told you this one was 9. Let's say this was 41 and this is 40. Now keep in mind these are right triangles, so they do have to satisfy the Pythagorean theorem. So I can't just make up whatever numbers I want. But if I wanted to find the tangent of A, the definition of the tangent is the ratio of the opposite to the adjacent. It is the opposite side divided by the adjacent side lengths. And from A right here, the opposite side, the faraway side, is 40. The adjacent side is the close side, which of course is 9. If we changed our orientation a little bit to maybe a slightly different one like this, and maybe I made this side 1, that side 2. Well, let's see, 1 squared plus 2 squared would be 5. So remember that's c squared. Now, as it turns out, I'm not going to need that because the tangent ratio never uses the hypotenuse. But the point is if I only give you two sides, you can always get that third side. So let's just say I chose to put B right here and I asked you for the tangent of B. And you always have to say which one because there's two different values you could pick. So you have to tell that what angle you're doing, and the tangent of B would be 2 over 1 because it is opposite over adjacent, which of course is going to be 2. But if we changed it and said C, and I said, well, what is the tangent of C? From C, opposite over adjacent would be 1/2. And you should notice that those are just reciprocals of each other. And so there's all sorts of problems you could do just to find the tangent. Now, sometimes we'll go a little bit further and we'll say find the side length. Let's do that. Find the side length. Now, that can be done a little bit differently. So let's see. Now, again, let's say we have this, but instead of saying, I know that this angle right here is a letter, what if I actually told you that I knew what it was, and it was 48 degrees? And I was able to tell you that maybe this side was 11 centimeters, but I don't know what that one is right there. Well, our definition says that a tangent of an angle, 48 degrees, is defined as the opposite, which is the faraway one, x, divided by the adjacent one, which is 11. Gonna grab a calculator real quick. But the nice thing is our calculators have all these values programmed in. So my calculator happens to know that the ratio attached to a 48-degree triangle will always be 1.1106. And so if I wanted to find that value of x, then all I need to do is I need to multiply both sides by 11. Kind of a fraction buster story. So if I just hit times 11, I found out that x would be 12.217 centimeters, since I said centimeters in the problem. Now, sometimes we get lucky and the problems are fairly easy. Sometimes they can be a little bit harder. Like I think for a lot of my students historically, it's not even so much that this is upside down. It's that if I said this angle was, say, 59 degrees, I know it doesn't look like 59, but I'm going to pretend that it is. And let's say I wanted to find that missing side. Now, again, I know that the tangent of 59 degrees is opposite over adjacent, the far away one divided by the close one. Remember, we always ignore the hypotenuse. I can cross multiply like I did on that last problem, but that's kind of weird because right now x is being multiplied by the tangent of 59. So of course, the last thing to do is since x is being multiplied, let's divide both sides by that. And we have a nice answer that x would be whatever 8 divided by that tangent would be. So let's see, 8 divided by the tangent of 59, according to my calculator, would be 4.807. So if that variable shows up in the bottom, we can sometimes make it a little bit better. But we have another option. And that is, if we know that this angle is 59, we could know that these two angles together, because this is already 90, these two have to add up to 90 as well. So 90 minus 59 is 31. So what I could do if I wanted to do that is I could say, I'm writing this in red to show that it's a little bit different. The tangent of 31, if I just switched perspectives, would be opposite over adjacent. And then all I need to do is multiply both sides by 8. Because again, if I could multiply by 8, those would cancel. And 8 tangents of 31, you're going to notice that x would be 4.807 again. So I find it faster sometimes to try the other angle to see if maybe that ratio looks a little bit easier. Now we can use this in a variety of ways. Like we can have a situation where, let's say there is a canyon right here, and like a creek or something like that, cutting through here, and somebody puts a pole over here, and we know that, say, this pole is 20 feet tall. And I can come across here and I could measure this angle. I could put a little transit is what you would call it right here. And I know that when I measure this pole, it is actually, I'm going to go with the number, let's say 49 degrees. And I really would like to know how wide the creek is. Well, again, that's very easy to do. You can imagine I'm standing over here. I've got somebody else standing over here. They hold up a stick. I know it's 20 feet tall. I can find out the thing. And then I could say then that the tangent of 49 would be opposite the faraway one. And as long as the person is holding the pole level, would be 49 divided by W. And so again, we can cross multiply. W tangents of 49 is 20. And so if we divided both sides, W would simply be 20 divided by the tangent of 49. The tangent of 49, there we are, and we got 17.386 feet. I would know that that creek is 17 feet wide, so if maybe I had a bridge that was 20 feet wide, it would be long enough to span and hit both sides. So that would be an application to do that. We could do it the same way. If we knew how wide the creek is, I would be able to find out maybe how tall the pole was, which could be, we've done a tree in class. Now, the last thing is Notice I can find a side length using an angle, but I can go the other direction and I can use the side lengths to find the angle. So again, we could use the angle to find a side, or sometimes we could use the side lengths to find the angle. And that's going to look like this. So last piece here. So imagine this is my point A, and I gave you a triangle that maybe had an 8 here and a 4 here. And it really honestly wouldn't even matter what this is. I want to know the measure of angle A, and I know that the tangent of A is 4/8, also known as 1/2. So all I have to do is ask my calculator. I had second tangent. I'm going backwards because I'm finding the angle, and I could type 4 divided by 8, right? And I got 26.5 degrees. But notice if I tried that again and I hit inverse tangent instead of 4/8, what would happen if I did 1/2? Well, one of the things that we should know is that those would be similar triangles. 4/8 and 1/2 would be proportional. So if triangles are proportional and similar, then their angles have to be the same. And what do you know? You get exactly the same angle whether you use 4/8 or if you use 1/2. Last one. I like to sometimes turn things over because people sometimes lose track of where the hypotenuse is. So on this problem, imagine I told you this was 17 and this angle was 5, and I wanted to find A and B. Let's find the measure of angle A and the measure of angle B. Well, what we could do is we could say then that the tangent of A is 17/5. So let's see, then I'm going to take the inverse tangent. Let me move this over. The inverse tangent of 17/5, and I got that that angle is 73.1.610. Okay. Now, in the same way, I could say that the tangent of B would be 5/17. It should be the opposite. So the inverse tangent of 5/17 would be 16.3. I guess 90. But you know what? We probably could have gotten that already because I know that these two angles have to add up to 90. So if I started with 90 and I subtracted 73, I got the same answer that I had right here. So again, you could do that problem a variety of ways, and I actually like doing it multiple ways on a test. And that way, if it doesn't work the way I know it should, I knew I made a mistake. Well, hopefully that's a nice quick look at the tangent ratio, and hopefully that was helpful. I will see you guys back in class. Bye-bye.